Alright, let's dive into one of the coolest concepts in quantum physics: wave-particle duality. This is the idea that things like light and electrons can act both like waves and particles. It's wild, but it's real. Wave-particle duality of light. Let's start with light. We know light behaves like a wave. You can see this with things like interference and diffraction. For example, when you shine light through a tiny slit, it spreads out and creates patterns, just like waves in water. But here's the kicker: Einstein showed us that light can also act like a particle. This happens in the photoelectric effect, where light hits a metal surface and kicks out electrons. To explain this, Einstein said light is made of little packets of energy called photons. And these photons hit the metal like tiny particles, knocking electrons loose. So, depending on the situation, light can act like a smooth wave or like a stream of tiny particles. Wave-particle duality of electrons. Now, it's not just light that's weird. Electrons, which we usually think of as particles, also show wave-like behavior. In experiments, electrons can create patterns that look like waves when they pass through slits, even though they're just tiny particles. But under different conditions, they act more like little solid objects. It's this dual nature, sometimes a wave, sometimes a particle, that's one of the strangest things about the quantum world. Why this matters? This wave-particle duality flipped our classical understanding of physics on its head. It tells us that in the quantum world, objects don't just fit into neat categories like waves or particles. They can be both, depending on how we look at them. And that's a huge part of what makes quantum mechanics so mind-bending. In short, both light and electrons can be waves and particles at the same time, and this concept is key to understanding how things work on the tiniest scales. It's one of the big ideas that reshape the way we think about physics. Title: Quantum Magic: How Particles Behave Like Waves. Let's talk about two really cool phenomena in quantum mechanics that show how particles, like electrons and photons, can act like waves: diffraction and interference. These concepts are key to understanding the wave-particle duality that's at the heart of quantum theory. 1. Diffraction. So, diffraction is when a wave spreads out after passing through a small opening or around an obstacle. This is something waves naturally do, but here's the cool part: particles can do it too. Take electrons, for example. If you send electrons through a narrow slit, they don't just hit a screen in a straight line like little bullets. Instead, they spread out, creating a pattern just like a wave would. This shows us that even tiny particles like electrons have wave-like properties. 2. Interference. Now let's move on to interference. This happens when two waves overlap, either amplifying each other, that's called constructive interference, or canceling each other out, destructive interference. What's mind-blowing is that particles like electrons can also interfere with themselves. In the famous double-slit experiment, when you send electrons one by one through two slits, they don't behave like particles should. Instead, they create an interference pattern on the screen, as if each electron is somehow going through both slits at the same time and interfering with itself just like a wave. Quantum mechanics connection. Both diffraction and interference give us solid proof of the wave-particle duality in quantum mechanics. These experiments show that particles like electrons and photons don't just act like solid little objects, they also behave like waves under certain conditions. This is something classical physics couldn't explain, but it's one of the fundamental ideas in quantum mechanics. So, in a nutshell, these two phenomena, diffraction and interference, are what make the quantum world so weird and so fascinating. Particles aren't just particles, they're also waves, and that's a huge part of what makes quantum physics so mind-blowing.